Hello, everyone. This is Mr. Coates. Um, I'm going to read to you in this video part one of David Dobbs' Beautiful Brains. Now, I say part one because I'm going to be breaking this video into a couple parts because this article is quite long. So for this video, I'm going to read paragraphs 1 through 24, and then the next video we'll do 25 to the end. So this is part one. Now, this as a warning, in the past, I used to do like 5 or 6 takes of these videos because I wanted to do them perfectly. And if I had a misstep, I would stop and start over again. But that just took forever. And so right now, I'm just going to give you the first take, and we'll see what works. If I stumble on my words, please don't hold it against me. You know what I'm saying. So without further ado, I will start reading. This is Beautiful Brains by David Dobbs, and this is located on page 3 of your reader. Beautiful Brains by David Dobbs, National Geographic, October 2011. Moody, impulsive, maddening. Why do teenagers act the way they do? Viewed through the eyes of evolution, their most exasperating traits may be the key to success as adults. One fine May morning not long ago, my oldest son, 17 at the time, phoned to tell me that he had just spent a couple hours at the state police barracks. Apparently, he had been driving a little fast. What, I asked, was a little fast? Turns out, this product of my genes and loving care, the boy man I had swaddled, coddled, cooed at, and then pushed and pulled to the brink of manhood, had been flying down the highway at 113 miles an hour. That's more than a little fast, I said. He agreed. In fact, he sounded somber and contrite. He did not object when I told him he'd have to pay the fines and probably for a lawyer. He did not argue when I pointed out that if anything happens at that speed, a dog in the road, a blown tire, a sneeze, he dies. He was in fact almost irritatingly reasonable. He even preferred that the cop did the right thing in stopping him, for as he put it, we can't all go around doing 113. I just noticed they spelled preferred wrong. Weird. He did, however, object to one thing. He didn't like it that one of the several citations he received was for reckless driving. Well, I huffed, sensing an opportunity to finally yell at him. What would you call it? That's just not accurate, he said calmly. Reckless sounds like you're not paying attention, but I was. I made the deliberate point of doing this on an empty stretch of dry interstate, in broad daylight with good sightlines and no traffic. I mean, I wasn't just gunning the thing, I was driving. I guess that's what I want you to know. If it makes you feel any better, I was really focused. Actually, it did make me feel better. That bothered me, for I didn't understand why. Now I do. My son's high-speed adventure raised the question long asked by people who have pondered the class of humans we call teenagers. What on earth was he doing? Parents often phrase this question more colorfully. Scientists put it more coolly. They ask, what can explain this behavior? But even that is just another way of wondering, what is wrong with these kids? Why do they act this way? The question passes judgment even as it inquires. Through the ages, most answers have cited dark forces that uniquely affect the teen. Aristotle concluded more than 2,300 years ago that the young are heated by nature as drunken men by wine. A shepherd in William Shakespeare's The Winter's Tale wishes there were no age between 10 and 3 and 20, or that youth would sleep out the rest, for there is nothing in between but getting wenches with child, wronging the ancientry, stealing, fighting. His lament colors most scientific inquiries as well. G. Stanley Hall, who formalized adolescent studies with his 1904 Adolescence, its Psychology and its Relations to Physiology, Anthropology, Sociology, Sex, Crime, Religion, and Education, believed this period of storm and stress replicated earlier, less civilized stages of human development. Freud saw adolescence as an expression of tortuous psychosexual conflict. Erik Erikson as the most tumultuous of life's several identity crises. Adolescence, always a problem. Such thinking carried into the late 20th century, when researchers developed brain imaging technology that enabled them to see teen brain in enough detail to track both its physical, developmental, and its patterns of activity. These imaging tools offered a new way to ask the same question: what's wrong with these kids? And revealed an answer that surprised almost everyone. Our brains, it turned out, take much longer to develop than we thought. This revelation suggested both a simplistic, unflattering explanation for teens' maddening behavior and a more complex affirmative explanation as well. The first full series of scans developing the adolescent brain, a National Institutes for Health project that studied over 100 young people as they grew up during the 1990s, showed that our brains undergo a massive reorganization between our 12th and 25th years. The brain doesn't actually grow very much during this period. It has actually reached 90% of its full size by the time a person is 6, and a thickening skull accounts for most head growth afterwards. But as we move through adolescence, the brain undergoes extensive remodeling, resembling a network and wiring upgrade. For starters, the brain's axons, the long nerve fibers that neurons use to send signals to other neurons, become gradually more insulated with a fatty substance called myelin, the brain's white matter, eventually boosting the axon's transmission speed up to 100 times. Meanwhile, dendrites, the branch-like extensions that neurons use to receive signals from nearby axons, grow twiggier, and the most heavily used synapses, the little chemical junctures across which axons and dendrites pass notes, grow richer and stronger. At the same time, synapses that see little use begin to wither. This synaptic pruning, as it is called, causes the brain's cortex, the outer layer of gray matter where we do much of our conscious and complicated thinking, to become thinner but more efficient. Taken together, these changes make the entire brain a much faster and more sophisticated organ. This process of maturation, once thought to be largely finished by elementary school, continues through adolescence. Imaging work done since the 1990s shows that these physical changes move in a slow wave from the brain's rear to its front, from areas close to the brainstem that look after older and more behaviorally basic functions such as vision, movement, and fundamental processing, to the evolutionarily newer and more complicated thinking areas up front. The corpus callosum, which connects the brain's left and right hemispheres and carries traffic essential to many advanced brain functions, steadily thickens. Stronger links also develop between the hippocampus, a sort of memory directory, and frontal areas that set goals and weigh different agendas. As a result, we get better at integrating memory and experience into our decision. At the same time, the frontal areas develop greater speed and richer connections, allowing us to generate and weigh far more variables and agendas than before. When this development proceeds normally, we get better at balancing impulse, desire, goals, self-interest, rules, ethics, and even altruism, generating behavior that is more complex and, sometimes at least, more sensible. But at times, and especially at first, the brain does this work clumsily. It's hard to get all those new cogs to mesh. Beatrice Luna, a University of Pittsburgh professor of psychiatry who uses neuroimaging to study the teen brain, used a simple test that illustrates this learning curve. Luna scanned the brains of children, teens, and 20-somethings while they performed an antisaccade task. I think I'm pronouncing that right. A sort of eyes-only video game where you have to stop yourself from looking at a suddenly appearing light. You view a screen on which the red crosshairs at the center occasionally disappear as the light flickers elsewhere on the screen. Your instructions are not to look at the light, and instead to look the opposite direction. A sensor detects any eye movement. It's a tough assignment since flickering lights naturally draw our attention. To succeed, you must override both a normal impulse to attend to new information and curiosity about something forbidden. Brain geeks call this response inhibition. In fact, by age 15, they can score as well as adults if they're motivated, resisting temptation about 70 to 80% of the time. What Luna found most interesting, however, was not those scores. It was the brain scan she took while people took the test. Compared with adults, teens tended to make less use of brain regions that monitor performance, spot errors, plan, and stay focused, areas the adults seem to bring online almost automatically. This let the adults use a variety of brain resources and better resist temptation, while the teens used those areas less often and more readily gave into the impulse to look at the flickering light. just as they're more likely to look away from the road to read a text message. If offered an extra reward, however, teens showed they could push those executive regions to work harder, improving their scores. And by age 20, their brains responded to this task as much as the adults do. Luna suspects the improvement comes as richer networks and faster connections make the executive region more effective. These studies help explain why teens behave with such vexing inconsistency. Beguiling at breakfast, disgusting at dinner, masterful on Monday, sleepwalking on Saturday. Along with lacking experience generally, they're still learning to use their brain's new networks. Stress, fatigue, or challenges can cause a misfire. Abigail Baird, a Vassar psychologist who studies teens, calls this neural gawkiness, an equivalent to the physical awkwardness teens sometimes display while mastering their growing bodies. The slow and uneven developmental arc revealed by these imaging studies offers an alluringly pithy explanation for why teens may do stupid things like drive at 113 miles an hour, aggrieve their ancientry, and get people, or get gotten, with child. They act that way because their brains aren't done. You can see it right there in the scans. This view, as titles from the explosion of scientific papers and popular articles about the teen brain put it, presents adolescents as works in progress, whose immature brains lead some to question whether they are in a state akin to mental retardation. The story you're reading right now, however, tells a different scientific tale about the teen brain. Over the past 5 years or so, even as the work-in-progress story spread into our culture, the discipline of adolescent brain studies learned to do some more complex thinking of its own. A few researchers began to view recent brain and genetic findings in a brighter, more flattening light, one distinctly colored by evolutionary theory. The resulting account left the adolescent brain, call it the adaptive adolescent story, cast the teen as less as a rough draft than as an exquisitely sensitive, highly adaptable creature wired almost perfectly for the job of moving from the safety of home into the complicated world outside. This view will likely sit better with teens. More important, it sits better with biology's most fundamental principle, that of natural selection. Selection is hell on dysfunctional traits. If adolescence is essentially a collection of them, angst, idiocy, and haste, impulsiveness, selfishness, and reckless bumbling, then how do those traits survive selection? They couldn't. Not if they were based on the period's most fundamental or consequential features. The answer is that those troublesome traits don't really characterize adolescence. They're just what we notice most because they annoy us or put our children in danger. As B.J. Casey, a neuroscientist at Weill Cornell Medical College, who has spent nearly a decade applying brain and genetic studies to our understanding of adolescence, puts it, we are so used to seeing adolescence as a program, but the more we learn about what really makes this period unique, the more adolescence starts to seem like a highly functional, even adaptive period. It's exactly what you'd need to do the things you have to do then. Okay, I'm going to stop now, drink lots of water, and then do part 2 right after this. Okay.